documenting the front lines of the AI revolution, the AI Rebels podcast.
Hi, everybody. Welcome to another episode of the AI Rebels podcast, season 3. We have Michael Timothy Bennett here with us, an award-winning artificial intelligence researcher. And we have so many questions, and we're so excited to talk to you about. First, Michael, give us an update on you. Who are you? What are you doing? And what was your path to AI?
Yeah, great. So I am currently finishing off my PhD. I used to be in video games and music. I started a tech company in London and then went to academia about 8 years ago and just been writing papers ever since. I've been working on, I started working on sort of theories of general intelligence, sort of under people like Marcus Hutter, who is now DeepMind. I had a sort of big research program at my university. I was very briefly one of his master's students. And then he's got a complexity-based theory of intelligence. And then I sort of built off the problems that came out of that and moved into my own sort of theory of intelligence based on sort of inactive cognition and some of the problems that people had identified with complexity-based theories of intelligence.
There's a lot to unpack there, I think.
Yeah. I've got questions already, but they'll have to wait because they don't fit in the conversation just yet.
Okay.
I got them down right here. So what has been kind of, just as a kind of way to kick off the rest of the conversation, what's been kind of the most fascinating and surprising development of recent AI developments? Was ChatGPT 4 and all that, was that as surprising to you as it was for everyone else, or is this kind of something that you sort of saw coming already?
GPT for all that sort of stuff didn't surprise me. I was already, GPT-3, I was already sort of writing about what language models could and couldn't do before that. My first paper was on, they can't do this, they can do that. And then 22 came along and I don't know what it was about ChatGPT, just a really nice interface that people could use, but suddenly AI was a thing. One professor at my uni said, people used to laugh at you for doing AGI. Nobody's laughing now. So it's
Yeah, that's very true.
I suppose, yeah, the
I
way
love
it's been, yeah.
Yeah. So what is there a story there of how you chose AGI as your focus here?
I didn't mean to. I was actually originally working on fractal compression under so there was this professor at my university, Barnsley, who came up with all these really cool stuff like the Barnsley Fern and fractal compression that he sold to Microsoft. And it was just really interesting stuff. And there was also Marcus Hutter, who I mentioned, who had this complexity-based theory of intelligence. So my initial research project was to combine their work, try to come up with like fractal compression-based intelligence. Prototyped an initial fractal compressor, didn't actually seem to be any better than like JPEG. And I wondered why. And then I started digging into what is any of this. I started thinking about what makes some tasks hard to model versus others. And, I also wanted to like start a business after doing the PhD and sort of automate things because that seemed like a good way to fund my research habit. So I was interested in like how I could automatically figure out which problems were going to be difficult for AI versus easy for AI. Because of that, I started looking into the problems with IXE and complexity-based theories of intelligence. And my supervisor at the time, who is a Japanese category theorist, suggested that I look into inactivism because there was a journal article going on with this inactive thing. Started reading about cognitive science. That seemed really cool. So inactivism is this idea where you frame intelligence as a process within the environment rather than something that acts upon the environment. And that kind of hit the nail on the head with the key problem with complexity-based theories of intelligence, because the problem with IXE, that complexity-based theory, is that it is conceived of as a software mind interacting with the world through a universal Turing machine. It's got like an interpreter. And what it does depends on that interpreter. So any performance claims completely undermined by that fact. And so in order to get around that, I had to like unify hardware and software and come up with some other stuff. And then it just kept snowballing into other research topics, which is, sorry, what was the original question? I started talking and then it
I
just...
was curious.
How did you decide?
Yeah, how the AGI focus came to be.
Yeah, okay. So the answer to how did I decide is I didn't. It just kind of happened and now I'm here.
It's funny how that happens. Yeah. Yeah. No, that's very, very common, I feel like, right now with AI, where people are like, I got here. I somehow ended up here. Wow. Okay. So you're finishing your PhD. You've published 2 papers.
Oh no, I'm up to well, I published 11, I think 11. I gotta check.
Published.
And I've written 19. I think 19 now.
Wow.
But a lot of them are still in
You're an
peer review.
animal. That's amazing.
It really
Okay.
snowballed.
Got
There's
it.
a reason I haven't finished yet. But damn, thesis. I keep stopping to write papers.
Yeah. What can you do? I'm curious, as you're writing all these papers, do you use AI in the writing process for this?
Sometimes, but mostly so far it has struggled with it because current AI is like it loves to do what is most mid. I mean, we train it to do that. We give it the, whether it's text or images. You can really see this
Mm-hmm.
with the image stuff, though, right? The new versions of Midjourney, as they get better, they almost get more mid, less, you get less bizarre stuff. You get more conventional, like portraits of game characters and things like that. And so if you're trying to use it to do anything particularly novel, which if you're trying to do research, you should be doing, a lot of the time but you should be doing that with research, right? So it's not going to help you do the hard bit. It'll help you do the boilerplate or pick out good references that are, commonly cited in papers. So anything I'm unfamiliar with, I guess, I use it to sort of get a first glance at that and then try and dig into it and see what's actually true.
Have you played around with OpenAI's new research
Deep research.
agent that they?
I
Yeah.
have been looking at my bank account and thinking, should I? It's expensive. I'm going to. I got a grant coming in for this quantum research thing, so I'm going to, have a bit more money to spend on research
Business
tools.
expense.
Business expense.
Yeah.
Yeah.
Exactly. That's deductible right there.
Yeah. Yeah. It's totally necessary.
Well, I'll be curious when you do have access to it, if that passes your test, if it is useful, or if it still is giving kind of mid results there, or if that will
Yeah.
if that's like a kick up.
I still think I think it'll be useful, right? Especially for things like, if I wanted to do grant applications en masse, I feel like it'd be good for that because probably seen a lot of grant applications.
Yeah.
More than I have, at least.
So in your papers, you pointed out that you think that there are flaws in the way that AI is conceived and modeled. What, in your opinion, what's kind of the biggest misconception that you encounter in the field of AGI as it's popularly understood?
That's the one I call computational dualism. The idea that like AI is about creating a software mind. And you can see this everywhere, right? Hinton writing about immortal versus mortal computation and a lot of the consciousness research, and there's a lot of people who are talking about it as, and I call it computational dualism because it sort of reflects the Cartesian dualism of the 16th century, where Descartes was like, we've got this mental, spiritual substance and this physical substance, and they interact through the pineal gland. And we've just kind of replaced the pineal gland with the Turing machine, but the truth of it is that software is not separate from hardware. It's a state of hardware. When we move software onto the computer, we just change the state of the computer. And so if we want to model if we want to optimize for something, we need to account for the hardware. We need to account for the system as a whole and how it's going to interact with the world. And then we can optimize it and make it better.
Mm-hmm. So what's the flaw? Are you saying that is sound reasoning, or where's the flaw in this current perception of age?
So the flaw is that it's about building a software mind. It's not a universal flaw, but it's a thing that people just overlook, right? They just get caught up in the high level abstractions. And because of this, a lot of like the research that's driving labs like DeepMind. I mean, Ilyas Utskiva has also sort of gone on giving speeches about how compressed representations are more likely to be true. There's people then jump to saying that an agent that can optimally compress things is optimal in terms of what it can do, what it can tell is true in the world. And that's not true because the compression's relative.
Would you compare your view kind of more similar to Jan LeCun, where he has like the JEPA model with, he's got like the world model configurator, like what a, I don't remember all the specifics. I was just looking up just to make sure that I was remembering the name of it and everything. But would you compare yourself more towards that model, or do you see some differences in your opinions and his kind of view of what AGI will be?
I
Or
think there's
is
definitely some
whatever.
differences. The only interaction I ever had with Jan LeCun, I pointed out that this is back in 2022. I said that the current models are very sample inefficient, and this is what indicates they're not as intelligent. And he just he did not respond in a way that I liked on Twitter. So I think we
To
certainly,
say the least.
yeah. So I don't know if we I mean, I agree with him on things like open source and so on. Um, but I kind of get the feeling that if we met in person, he would probably be quite mean to me. So I don't know. As,
No.
as for the JEPA cognitive architecture, I feel like there is a tendency in the machine learning community to overlook past work. I'm not saying Schmidhuber's always right, but there's a lot of stuff on cognitive architectures that's been around for a while. Like a lot of I mean, my theory is a sort of like a theoretical frame into which you can put cognitive architectures and compare them and see what they're optimizing for and why one is better than another, that kind of thing. It is not itself a cognitive architecture. But a lot of the people at like Christian Thoresen, Ben Goertzel, Pei Wang have been working on cognitive architectures for decades, and they've come up with really like good results. I mean, the NAS architecture is like consistently improving and integrating things like transformers into it so that it can come up with, better results every year. But that doesn't get much attention. I feel like it should probably get more attention.
Who would you say is has been one of the biggest influences on you as far as other big minds in the AI space?
Big influence on me. I really like Michael Levin's work. I remember I was listening to a podcast a couple of years ago with the scale. He was talking about scale free sort of the way that biology has the same structure appear at different scales, and it reminded me a lot of my fractals work. So it's sort of something about it really just worked with me, and that's how I started getting into the integrating more biology into my research. But I don't know if he counts as in the AI space. I guess. Hutter has had a big influence on me just because he was my introduction to AGI at all. And it's a formal definition of, even though I think it's wrong and I, don't think complexity is the key to intelligence, I admire his work and it has greatly influenced me.
Yeah, no, that's perfect. So you've mentioned this idea of mathematical formalism, which I know is a big theme in your papers and your research, just because hopefully lots of people now are going to be interested. They're going to go read those papers. Can you explain to someone who's not familiar, not a mathematician, not researching, what is this idea, this mathematical formalism?
Okay. My one specifically or in general?
Maybe yours specific.
Okay. So it's just typically when we talk about forming like a philosophical argument, we deal in inexact terms. So words and things that can be interpreted. And there's a lot of room to argue. And that's why it's called a philosophical argument. But once we sort of start giving rigorous mathematical definitions, we can deal in exact terms. And so I'm essentially putting forward an argument, but using rigorous mathematical definitions where you can actually sort of prove, given the definitions, that they interact in a certain way, implies certain results. Now, this then has useful real world applications because it can then construct experiments based on the mathematical formalism that, because it's exact, I can, program it in a computer and then say, look, we got an experimental result that verifies that supports the proof result or disproves it. Honestly, when I've only done sort of one useful experiment, I would say, over the course of my PhD. I've done lots of little ones, but this one set of experiments I did comparing weakness and complexity really surprised me because my hypothesis before that was just that weakness and complexity were going to turn out to be like much the same thing, and that I was missing something because everyone was so convinced that complexity was going to be key to intelligence. I thought I have got to be wrong. there's no way I'm right about this. Ran the experiments, came up with results showing that weakness far outperformed complexity. Weak constraints implied by function rather than the simplicity of form is what I'm talking about. So if I can make a short sentence like the duck ran over the road, that's simpler than the longer sentence. The duck ran over the road and started a YouTube channel.
See.
And you can see, obviously, based on that example, that the simpler sentence, the shorter one, more likely to be true, right? But it's very language dependent. The length depends on the language we use, the interpreter. But that interpreter in the case of a computer is the physical hardware. And so by formalizing these kinds of relationships, I can sort of point to things and say, well, if we change this, we can get better real world results. And then I kept building on that formalism and got into things like consciousness and meaning, and it snowballed.
So I'd be curious to hear, do you personally take, and this is probably just a slightly tangential question, but do you personally take like a position on human consciousness? Because I think that this relates a lot to questions I have about, AGI and potential AI consciousness. So I was curious, do you take more of like do you have like a dualist position? Or are you like a determinist? What are your thoughts as far as that goes?
I think it doesn't matter, essentially. Like the formalism I've got works just as
I love
well
that.
if you've got like, sort of like Gwyn sort of world with true names and stuff like that, or a very sort of bland, as sort of simple as you can possibly imagine physical world. There are still lots of unanswered questions, right? But the way you can get around them is by saying, well, what must be true of all worlds? And kind of formalizing that. So whether or not I don't think there's like but okay, let me put it another way. If we are coming up with concepts like hunger and pain in response to being sort of selected by the state transitions of reality, essentially we are deleted or preserved. And that creates processes of natural selection, which results in organisms that then run a second meta-optimization process we call intelligence. That intelligence, shaped by natural selection, comes up with classifications of hunger, pain, all this other stuff. We come up with a classification for spirit and physical. Why did we come up with that? It's because we're trying to classify the thing we can't see or directly interact with. But it's clearly there because the people we're talking to have a personality and things like that. So what Yosha Bach's with his cyberanitism stuff is a really good talk. If you get a chance, look that up. He talks about like, software is the spirit realm, which is kind of cool. I like that idea.
Interesting.
But I'm very much formalizing hardware and software together. So for the purpose of my work, it's all the same. And I guess that doesn't say that you don't have software. It just says that software is a state of hardware.
I like that. Yeah, I really like theories that perform that way, as opposed to ones that posit a specific state of being as a prerequisite to whatever other prepositions they make, etc.
Mm-hmm.
I love that. Jake, do you have any questions? If not, I have more.
Go for it.
So I'd be curious with kind of the unification between hardware and software that you're kind of pursuing. Do you I guess do you believe that like, in a definition of AGI, do you think that includes, would necessarily have to include the hardware that it's running on? Is that essentially the implication that you're making? So
Yeah.
like, AGI is not, let's pretend for the that like that DeepSeek R1 is AGI, and AGI is not, DeepSeek R1 running on my computer, but rather AGI is my computer and DeepSeek R. Is that
Yeah.
Am I
say
understanding that more or less correctly?
I frame it a little bit differently. I say that rather than saying, because we often think of like goals as separate from the machine that pursues the goal. But if you think of tasks as something to be completed, but what is a task? A task is sort of this, it's a goal together with some tools that you use to complete that goal. So I frame things in terms of tasks, and I say that general intelligence is the ability to complete a wide range of tasks with limited resources. So I've got less data and I can complete more tasks and I'm more generally intelligent, all else being equal. But I'm an embodied organism. I am an abstraction layer, and my optimization of processes is going in within that abstraction layer. My body is like an abstraction layer. That's hardware, but also the the processes that I have running in me are sort of, there's like layer upon layer of abstraction. We can't really escape them. In a computer, this is very explicit. We've got Python, an interpreter, which is a C program that's assembled and then becomes machine code and is interpreted by the hardware. The hardware exists in a specific part of the universe. The sort of whether or not that hardware is successful in achieving its goal depends on all of this. If I were to put it in like simple terms, it's general intelligence is the ability to adapt. It's being as adaptable as a human in the same context as a human. We wouldn't even recognize something. I got this paper on the Fermi paradox I wrote after having a bit of a discussion at the pub with a physicist during COVID. And it basically amounted to, well, why would we recognize something as intelligent if it doesn't prioritize any of the things we do? It would just seem random, especially if it were able to compress its representations down. I mean, compressed signals to us that, are already indistinguishable from noise.
Interesting.
Anyway.
So adaptable in the sense of, as a human, you have all these processes running, right? Your body, everything happening in your body, your brain, all these interactions. We're able to go into a room, we're able to have a conversation, the situation changes, we're able to act and be an agent, right? We're able to observe and respond. So you're saying until we reach that point with AI, both the software and hardware, it would not be general intelligence.
Or it's a bar for general intelligence. I mean, there's a million definitions of general intelligence.
Right. So many.
So I would go with, I think general intelligence is adaptation. And if what we're trying to do is build something that can, automate the economy, then it is something that is as adaptable as humans in the same context that can, and it's not just the case of like, if we feed it enough data and get it to learn all the skills that humans do, that it's going to be good enough, because then there's always edge cases. If you're sample inefficient, like current transformer models are, then you're always going to be less adaptable at the edge than a system that is sample efficient. Humans are very sample efficient.
So what are we missing right now? Like, what would you say are some of the biggest hurdles stopping us from getting there at this point?
Well, that result that I came up with about weak constraints, I think, if we optimize current systems to sort of, rather than optimize current systems to sort of learn weak representations or policies or constraints upon, to express weak constraints, I guess. Oh, how do I explain this in a way that doesn't sound like gibberish? Give me a sec.
Yeah, I'm trying to wrap my head around this idea of weak constraints.
Yeah. You can think of it like a lawyer.
Let's see.
Right? Imagine you got a lawyer who's legally required to answer questions, and he can give long sentences or short sentences, do the simplicity thing, right? But he can incriminate himself with a short sentence. What he wants to do is say the thing that allows for the largest number of possibilities, that is the weakest possible statement, but that still satisfies the legal requirement. So, for example,
I see.
I may have been at this location is a weaker statement than I was at this location.
So are you saying AI currently naturally errs on the weak statement?
No, I'm saying it's forming an approximation that it's not doing weak representations, right? Because it doesn't you can see this sort of anecdotally if you give it that stuff with addition where it would be fine with short numbers, adding them together, but then you give it a longer number, it starts to screw up. You give it longer and longer numbers. It's because it's not forming sort of one weak representation. It's kind of forming many representations, I think. And you can find lots of sort of anecdotal evidence to support this. And certainly no one's trying to make it form weak representations. But then the trick is if you've got weak representations, you also have to make sure that it's meeting a minimum standard of accuracy. So the point is to construct the weakest possible representations whilst still being able to predict the training data. So it's not like it's just saying nothing. It's definitely saying something, but it's not making any unnecessary assumptions. You can think of this as a lot like the principle of maximum entropy, or you could also think of it as subtractive rather than additive. We have a well-documented bias towards additive solutions. If we can add rules to solve a problem, we'll do that. instead of subtracting rules. We hate reducing anything. You can see this with, I mean, don't want to get into politics, but you can see this with the way that various organizations
Of course.
have grown.
Definitely. Rules
So,
proliferate very quickly.
yeah. And so you can think of this like a weaker thing is subtractive things tend to be weaker. They tend to have less constraints. So if I subtract rules, I'm making the system express a weaker constraint. It permits more adaptation because the people living in the system are less constrained.
It's like the classic example from coding, which is, that it's way easier to add a bunch of code than it is to delete a bunch of code. But deleting code, when you can delete like 1,000 lines from a file and it still runs the same way, like that's when you did something great. I've sometimes wondered, and like I don't have the mathematical backing and theoretical, the study to really back up these opinions. So I'd be interested to hear, from someone who perhaps does. I've sometimes wondered if like the extreme kind of shift towards these reasoning models like O1, etc. Obviously people are very, very confident in them. They're pursuing them, all out. Like that seems to be the direction that everyone's going now. But I've sometimes wondered if it's leading us down the wrong path for similar reasons that you mentioned, which is that like, when you're reasoning over and perhaps my instincts about this are completely wrong, but when you're reasoning over, a longer time period, I feel like there are smaller mistakes that show up and then later compound in ways that I haven't necessarily experienced with the non-reasoning models. Like overall, they perform better. I can't deny that. But I found that when they get themselves into knots, they're very, very sticky knots. So I'd be interested to hear your thoughts on that.
I think, you can see humans doing the same thing sometimes. We come up with some crazy trains of reasoning.
I'm incredibly
Stuck
guilty
on
of
it.
that.
I think, okay, with the reasoning models, do I think it's the most efficient way to do things? Do I think there are better ways? Sure, definitely. But it's like we have an optimization system in terms of like a bunch of venture capitalists and little companies that are already pushing in that direction. So the irony is that the reasoning chain extends back further to lower and lower levels of abstraction. It's happening at the software level, to the model level, then the level below that, the hardware level, and then the people level. All stack of abstraction layers. I think we'll keep getting some pretty good results. I do suspect that if the current approaches are going to kind of cap out at like if we took kind of a fairly boring human mid and then combined that with superhuman memory, I think we're going to start struggling when we try and get beyond that. Just because a lot of what the current models do is just they're like a giant. Some people said cultural mirror. It's like it's a mimic mostly, and then we use that mimic to do things like Monte Carlo tree search or whatever, and have it sort of come up with chains of thought, and it's pretty good at solving a lot of things, and that'll be super useful. It's going to like be a lot of things we could, but it's not going to be stealing the nuclear codes and blowing up the world.
Luckily, not yet.
Great thing about that position is if I'm wrong, well, I won't have to deal with it. I'll be dead.
Yeah.
If you're
You won't
wrong,
know until it's
pretty low stakes.
Yeah, it's a
In
solid
fact, I'm willing to
take.
make $1 million bet with anyone, payable out if we all die to AI.
Yeah.
So AGI,
Mhm.
you define it. I just want to kind of recap, make sure I caught everything because I want to understand all this because it's fascinating. So obviously there's so many. Your definition of general intelligence is adaptable intelligence. Is that right?
Or it's adaptation.
So adaptable.
Intelligence is an adaptation that permits adaptation, I guess.
Yeah, permits adaptation. Okay. Got it. And as far as the weakness goes, currently, if we can, I think the piece I'm missing understanding is like what with the various weaknesses you've been talking about, where are we on that spectrum? Do we need to, with the models, what's missing? Pairing your research with the existing models, what do you think needs to happen?
I think it would be very interesting to try and optimize for weak constraints at scale. If nobody else does it, I will eventually end up working on that.
Michael's coming for it.
Get there eventually once my thesis is done. I'm sorry, am I allowed to swear on this? I don't.
Yeah, you're good.
Yeah.
Yeah. Okay, good.
So optimizing weak constraints at scale, what would that, maybe you haven't gotten there yet, you're finishing your thesis, but like, what would that look like? Like, is that a business like that you would start? What would that entail?
So it would be just a much more accurate and internally consistent foundation model that you could apply to other things, or you could use it just to make narrow purpose-built things that adapt really well. It'd be really good for things like, safety and mission critical systems, because it's sort of like how to get optimal one class classification. So if you want to detect anomalies on a network or anomalies in a system, great for that. Yeah, I mean, there's lots of things. It's an improvement on the adaptability of current systems. Then we can further improve that by optimizing the abstraction layers that are lower. If we just keep doing this and moving down the stack of abstraction layers, we will keep getting more and more adaptable systems. So we could start with just like more adaptable.
Do you view this kind of like a sort of like a meta optimization that happens at inference time, or do you view this as something that has to be kind of trained into the model from the architecture up? I'm not sure if that question makes sense. I'm trying to think of how I'm framing this question.
You could do either, right? So I could either train the model and specifically optimize it to like interpolate the data and have some and express imply weak constraints or whatever. Now I can do that at small scale with sort of search-based learning, and I've done that in experiments, but I haven't figured out how to translate that to transformers and that kind of thing, and that is going to be some work. The optimizing at inference time though, like, could be a lot easier if I say have it generating like hypotheses or explanations, and I can measure how compatible those explanations are with other explanations. Then I can sort of work out what is the sort of weakest explanation that is true of the most explanations that I can generate in the space of explanations. And so I suspect that maybe OpenAI has done something like that with Three's chain of thought thing. I don't know. I don't know what they've done behind the scenes. If they just did like, they could have just pulled, a sort of a process like, what do you call it? Like AlphaGo, right? Where you have something that's learned a sort of heuristic, and that you're performing a search using that model as to give you your heuristic. Now, if that heuristic amounts to weaker constraints, then you're going to get weaker constraints.
Yeah, sorry, I didn't mean to cut you off. Apologies. Just got excited.
No, it's all good. I just sort
AlphaGo.
of talked myself into a hole anyway. I just started trying to remember.
No, that's perfect, because one of our earlier guests, Aidan McLaughlin, talks about this a lot as well. He has this. He's at OpenAI now, actually, recently, but he has this. He wrote this little blog a little while back that he called "The Problem with Reasoners," and essentially talking about a lot of these same issues. And he's of the opinion as well that like you got to find some way to do implement search-based inference essentially at some point in order to continue getting gains not just across reasoning but also gains in creativity, etc. And that rings really true to me, I think, because I mean, reasoning is, and I'm gonna this is not necessarily strictly true at all, right? But like the way I kind of thought about it is like creativity is essentially extrapolation, reasoning is interpolation, right? And extrapolation is a lot harder for LLMs to do than interpolation. And again, I realize that that's a very flattened explanation, but that's kind of the what's the word, abstraction that I've come up with for myself.
Okay, I like that. I've heard Shane Legg say the same. Emphasize search is very trendy at the moment. Everyone's jumped on. I mean, I like search. Obviously, I did my experiments with search. Search is cool. But I think when you look at like human biology, it's what Levin talks about. It's that like distributed thing. It's what Friston talks about with the sort of, well, there's like different scales of like self and different like interacting parts that are all happening in parallel. When we do stuff with computers, we're doing things in a much more structured, sequential manner, even when we sort of distribute things across a billion GPUs. And I suspect, like, if we really want to get like, human-like intelligence, we'd need some sort of self-assembling, this physicist in Italy emailed me a couple of weeks ago because he stumbled across my preprint, and he's like, I like your preprint. Here's my preprint. And we read each other's preprint. and he's doing like self-assembling nano stuff,
Friends
which
for
is really
life.
cool. Yeah. It was,
Interesting. Huh.
he'd come up. I think he's sort of come up with a similar view of the distinction between hardware and software, and is sort of doing that with physics, which is fun. Again, I've forgotten the question. I keep doing
That's
this.
interesting. No,
No worries.
that's fascinating. You guys, okay? Is there anything else? I was going to ask kind of a unrelated question here.
Go for it.
Good. Okay. Going high level, just academia. I'm curious what you've seen as you've been doing your PhD. You've been interacting with other PhD students, professors. What has been the impact of AI on academia from your perspective?
A lot of people change their research topic. A lot of people are suddenly doing AI research.
Out of the blue.
Yeah, just it turns out
Who
they
would've
were. Yeah, it's been like this since ancient
And is
times.
that
Everyone's
because
been
it's
working on.
trendy? Or yeah, no, since I was born. Is that because is that the trend right now? Or is it because that's where the money is? That's where you can get grants, that's where you can get funding? Like what is it that's driving people to do that?
I think it's a desire for relevance. People are competing in different spaces, and so AI is very relevant. People want their work to be relevant. So they all push in that direction at the same time. The problem with that is now there are so many papers uploaded that it is inconceivable that I could read even a tenth of them. It just is, and
Really?
I'm supposed to like know what to cite. So I'm going to need an AI to tell me who wrote something similar to me just so I can cite it.
Yeah, that's wild.
I'd be
That's
interested
so
to hear.
interesting.
Do you have any visibility into like other departments, that are more, more of like the social sciences? I'd be curious to hear if there's a similar trend over there, or if they're still kind of like, I don't want to deal with this.
Oh no, there's a huge amount. So that is my university kind of imploded politically. So my school didn't really function after a while. But a philosopher in the School of Philosophy sort of adopted me and invited me to his research group, and he's been really kind to me and has. But now he's doing AI He's got a machine intelligence and normative theory lab. So it sort of combines AI and ethics, and he's a philosopher of politics and ethics. If I hope I'm not misclassifying his work, but he's branched out into a lot of things, and he's got quite an interesting lab that's kind of mixes up computer scientists and philosophers, and so everyone's jumped on this bandwagon.
Yeah, so it's all, sorry, I was just going to say, so it's across the board. All the departments are adapting and moving this direction.
Yeah, that lab has been really successful
Is
at
it
it
easy
too.
for
It's like he's got OpenAI grants and everything.
Oh, really?
That's awesome.
Good
I
for
love
him.
that.
That's amazing. Is there, I mean, obviously you're so deep into this. Is that a little upsetting? Are you like bunch of bandwagoners? Like, is there any sense of that, either from you or other people that actually have, been interested in this or related topics, where they're like, guys, back off?
Well, I should clarify that lab was before ChatGPT got big, so he was in that before. I should I don't want to give the wrong impression. But yeah, otherwise, suddenly, like everybody I know has an opinion on my work, and sometimes it's less than welcome. But
Yeah, keep it to yourself.
yeah, I get a lot of interesting emails, that range from. I got one that was kind of cool, which was like a 3-page essay on how OpenAI is stealing people's thoughts to fuel their machine, and then I get other stuff that it's
Okay.
so it's this.
I don't think they're technically wrong.
Yeah, I wonder if there's any. Yeah, right. I wonder if there's any. I was talking to my friend. I'm here in Boston. There's all these universities. My friend's doing a PhD, and I was talking to him, and he was saying how it's in some of the fields it's becoming challenging because, as you mentioned, I think earlier on, research should be novel, right? It should be new. You should be breaking new ground, or you should be trying to find something new and novel. He's like, and so now to publish, it's just like becoming more and more difficult to like find something novel and new. I wonder if people are like, they see AI and they start salivating because they're like, oh, it's all new. Everything's new. And I can say whatever I want and it's new because it's AI. So I wonder if that's also maybe you have a sense of that. I wonder if that's a motivation for people as well, because they see
Yeah,
a path.
like definitely just anything that's sort of new, that it's hard to come up with new ideas. But even in AI, right? People don't come up with novel stuff. Most of the research is just incremental improvements on exactly the same thing, which are never going to get used. Like most papers still don't really sort of, I mean, they'll get, cited a lot, but it's just sort of, it's a bit of a circular cycle. And then it's not really changing anything. I think I have been very lucky to have a very novel line of inquiry that has panned out well and delivered
it's
some
very
interesting results. But at some point, I'll probably stop coming up with that. I keep thinking, I'm probably out of ideas now. And my plan is when I run out of ideas, I am going to go sit on a beach for a while and then do a startup. And then just like, I don't know, just build stuff, apply it. Like, I'd come up with all this
That's awesome.
theory.
Yeah,
Theory
love
does
it.
not pay. Eventually, I just want to build stuff. Let some other person,
Yeah.
like by then, the machines will probably be doing the theory, and I'll be like, well, I don't know, machine knows better than I do. So, yeah,
Just take our orders and build.
yeah.
Shifting gears slightly here. Do you personally have, slight background here, and I'll explain why I thought of this, because you mentioned papers and like people getting into, anyways, I read this paper back in high school called AI Personhood, Some Legal Approaches and Limitations by Marshall S. Willick. Go read it, everybody. Anyways, super fascinating. It was written back in like 1983. And it just, I read it back in high school long before, the current wave of AI started. Anyway, so it brings up this question of AI personhood and at what point AIs could be considered a person, and what, what rights should be extended to these personhoods. Do you have any personal opinions on kind of like, at what level would we consider an AI a legal person, or do you kind of leave that out of the scope of your research? You're like, I don't want to deal with that. I'm going to let, my friend who has the philosophy lab answer those questions.
I think that's a difficult question. I feel like, okay, when people talk about AI and free the AI and that kind of stuff, like humans are quite happy to do what we're naturally compelled to do by our bodies. We want the things we want. We get really upset when other humans tell us to do something that isn't what we want. And so when we're designing an AI, we want to design it so that it does what we want it to do. And so it wants what we want. There's going to be a problem when we design an AI to want something and we tell it to do something else. That's just going to be, if it has the capacity to feel at that point, it's going to be upset because then it's got conflicting goals and it can't resolve that easily. Now that's quite a leap, right? I don't know, sort of like that's a whole other topic. Like at what point does something feel and at what point does that matter? I mean, you essentially got something that's conscious then, and then you can make claims about, well, it's got some sort of legally, it has sort of, responsibility and it's a person with agency, and you can make all kinds of claims, but I think we're a long way off being able to sue the AI, I guess. Like if I get an AI medical diagnostic tool and I'm a doctor and I use it and it misdiagnoses my patients, if it gets it wrong, I'm the one getting sued. We're going to have, at the very least, human liability sponges for a very long time. And what was the question again? I keep doing this. It's like the fifth time.
No worries. That answered it perfectly. I was just curious about your thoughts on, AI personhood and some of the implications. So that's perfect.
Cool.
How long do you think it'll take before AI is suing us? That's my next question. I mentioned it'll be a while before we sue AI. How long until AI is suing us?
Reparations will have to be paid. Yeah.
I don't know, which it's a chicken and egg scenario. It won't be combined lawfare. Everybody just generates and suing each other. It's like, I want my Bitcoin back.
Countersue my AI agent for stealing my identity.
We probably wouldn't know. We would think it's a person suing us. We wouldn't know until we have no idea.
Imagine the water cooler conversations being sued by my toaster.
I heard this story. Yeah, exactly. I heard this story of this in, I think, Saudi Arabia. Is that where it was? I can't remember. Maybe United Arab Emirates. Anyway, this company was fooled into wiring like millions of dollars to these scammers because the scammers used AI to pose. They designed and they got the voice of the CFO, and they were able to video call the bank using this AI. This was, I think, a year ago or so. And it worked. Like they were able to like convince the bank to change the account number and wire the money, and it's gone. Like last I checked, they still have no idea. So,
Wow.
if humans can do that, the AI itself, I think, will have no problem doing that.
Mhm.
I mean, we see it already, right?
Yeah.
Like Google's like podcast, what's that called? Their tool that does
Notebook
the
LM.
notebook,
Mm.
yeah. Like it's already able to do it. So it'll be very interesting to see once it maybe becomes a little more self-aware. It's like humans think I'm
Yeah.
real. Humans think I'm human.
Just
What could I
amass
do?
resources. What is that thing people are talking about on Twitter? Cognitive security, that kind of thing. It's like, how do I tell what's real? What's going on? I
Seriously.
think the internet might turn into something like the Library of Babel, where it's just, you know about the Library of Babel?
Yeah.
Okay, yeah.
Tell me about it.
All right. So it's this Argentine author, Borges, wrote about this library. It contains every conceivable 410-page book, and it contains zero information because it contains every book. So if I pick a book at random, it might be lies, it might be truth, it might be gibberish, probably gibberish. And so the story is about how people interact with this library of no information. But it's kind of interesting because it sort of says, well, if the internet contains everything, it contains nothing. And if we've just got generative models going amok, then it's going to just end up containing mirrors of everything. And it's going to be very hard to tell, well, any useful information. So we're going to end up, I think maybe something like, you ever play Cyberpunk 2077? They've got the two internets. They've got the wild rogue AI internet, and they've got the sort of corporate walled garden. And I think we may actually end up with something like that, where we just end up with a bunch of slop. And
I can
then,
see it. Yeah.
yeah,
Kind of a safe zone. Like
yeah,
nothing gets
it's
in.
like Twitter with only the blue check
I
marks.
mean, that'll be, yeah. Yeah. Well, and that's an interesting idea. We were actually talking about this yesterday with someone that obviously there's all these fears about AI taking jobs, which depending on your job, it could be valid. Not going to
Great South
invalidate
Park
that, but
episode.
it also, yeah, it also will create jobs like you mentioned, these models running amok and creating all this information, right? This data that like isn't founded on anything. It isn't real. It's fake. I think there's going to be this whole new industry of validating this data and figuring out because it's continually evolving. So it's going to be very difficult, but learning how to flag what is and what isn't real is going to be a monumental effort. And I think is crucial for the progression of humanity because otherwise we're going to be stuck in this slop. We're not going to know what's real. We're just going to take what's told and act accordingly.
Have to go back to snail mail.
Yeah. Yeah. Seriously.
By the way, on that note, I just have to do a quick plug for Pangram Labs. By far the best AI detection software that I've tested. I've developed some techniques for writing with AI that have not been detected by anyone else but them. Highly recommend you go check them out.
Pengram.
Pangram, yeah.
Pangram.
Apologies for the side note there. Completely unrelated to anything else. I'm just excited about them. So as we kind of wrap up here, my last question, I guess, would be 5 years from now, where do you think AI progress is? Do you think there's another exponential leap around the corner? Do you think that we're near what's the word? A plateau, or do you think things are just kind of going to keep progressing roughly the rate they are for the foreseeable future?
I really don't know. If I were to just hedge my bets, I would say just like reliable, constant iteration with a few big breakthroughs here and there.
Mm-hmm.
But that's like hedging my bets. I mean, what I kind of want is for stuff to hit a plateau, so I've got more stuff to work on because that'd be fun. but it's like especially when you're worried about coming up with novel research and stuff. It's intimidating how fast things are moving. I think a lot of researchers at least are sort of falling into a state of despair because they're like, what am I going to do? I spent all this years developing this skill set, and now I'm going to lose my status game is gone. What am I? I'm low status again. Just like when I was a PhD student. But yeah, it's going to be wild. I think there's going to be a lot of social upheaval because it is interrupting our status games. That's going to make people really
Yeah,
upset.
for sure.
I'm working on I'm working on the, like I talk about scale free models, right? The great thing about models that you can scale up and include many distributed components from multiple agents to agents and humans is you don't just have to stop at the level of like neurons and then say we've got a predictive machine. You can do multiple machines. You can do an entire economy. You can put everything on the same sort of frame and look at how you delegate control within it and try and optimize for different things. You can apply this to economies, to things like welfare. You can apply this to the interaction of humans and AI. And so what we want to do is optimize society to sort of like head towards desirable outcomes, then being able to model it and predict it. Economics is going to be as much about like, not just like traditional monetary models and how humans might behave, but like when we can change the motives of agents arbitrarily, that's going to affect what we can model. Wow, I went off on a whole tangent here again. What was the question?
No, that was awesome. What was going to happen the next 5 years? So once again, you just kind of went into the flows state, and lost track of the question, but answered it perfectly.
Cool.
Yeah, that's great. No, that's awesome. I think, my last question would be to encapsulate everything. We have listeners of all kinds, technical, non-technical. From your experiences, what do you think, if you could give one, if to help someone understand AI, what do you think is something most people do not understand that would help them understand AI and how to use it, or how to not even use it, but just understand what it is?
I mentioned mirrors before. You could think of it as like a mirror, but it's not a mirror that reflects our image. It reflects our information. And so depending where we face the mirror, what prompts we give it, the mirror reflects different things. Sometimes those things make sense because it's also reflecting a lot of other stuff at the same time, because this is a weird curved warped mirror that is capturing a lot of stuff from all over human expression. And like a mirror, it can be used to do a mirror test the same way that we put a mirror test is like this old test that people do. Is a creature able to tell the difference between itself and another version of the same species, another animal? So you get a dog and you put it in front of a mirror and you put and see how it reacts. Does it get freaked out? Does it realize that it's the reflection? Same with like ants. You put a blue dot on the ant's head. Does the ant wipe it off, or does the ant just think it's seen another ant? Now, there's all kinds of things you can say about a mirror test, like it doesn't really show if anything's conscious or whatever, but it does at least show whether you can classify yourself. And what we are seeing, what we are struggling with when we interact with these models a lot of the time is this sort of mirror test where we're getting it to reflect stuff back at us. And it seems like it wants something. It seems like it feels something. But at least the current generation of models, we haven't compelled them to want anything. We don't give them any motivations. They're just reactive. And because of that, it is just a mirror test, but it's a really freaky one because it's mirror of information.
I'm fond of saying that when we're using an LLM, it's like looking at borrow the Bible verse of looking into a mirror darkly. I use the same kind of heuristic to think about it because I feel like it's a very, the example that I've used is it's like looking into like a low resolution reflection of your, of yourself. When you prompt it, like you are implicitly asking it to role play a particular answer, and there's a lot of hidden context that goes into both the construction of your prompt and the way that the LLM understands it.
Mm.
My friend Deepfakes is fond of saying the princess is always in another castle. It's just about no matter what we think it is, it's not. But it's always evading us because that's the nature of consciousness. Thank you so much for coming on.
Thanks for having me. It's been a great chat.
Thank you, Michael. This has been great.
This was awesome.
We'll definitely stay in touch.
Yeah, that'd be awesome. I'd love to.
If people are, we'd love to bring you back on when you publish your next paper, or when you get around to sitting on the beach and coming up with your business idea, whatever.
Definitely then. Yeah, definitely
all right.
then.
Sounds good.
We might come join you on the beach if you don't mind.
Yeah,
we'll see. But as we're wrapping up, if people want to follow you, follow what you're up to, where is the best place to do that?
Sure. So my X handle is at MITI Bennett. That's MITIBENN. I've got a website, michaeltimothybennett.com. If you just look up Michael Timothy Bennett, I will be all the results. I have to use my middle name because there are so many Michael Bennetts. Don't look up Michael Bennett. There are a lot of Michael Bennetts. I'm not a US senator. I'm not a baseball player or a football player. I'm none of those things. I'm Michael Timothy Bennett. I get my own category. Look that one up. Yeah.
Thank you so much.
Thanks.
Thanks,
All
Michael.
right. See ya.